In this video, we'll be doing a motion word problem. The components distance, rate, and time are denoted by the letters D, R, and T respectively. These variables are related by the equation D equals R times T, or distance equals rate times time. Now, the first step when you're solving a word problem is to read and analyze the problem. So, Chrissa drove to her grandmother's house for a weekend visit. She averaged 40 miles per hour driving there on Friday. Returning home on Sunday, traffic was lighter, so she was able to average 48 miles per hour, and her driving time was 1 hour less. What is the distance between Chris's home and that of her grandmother? Now, as soon as I recognize that I have a distance equal rate times time problem or a motion problem, I use a graphic organizer to organize the information that I'm given and my variables. So I'm going to draw that right here, and I'm splitting my box into 3 columns. My first column will be distance, my second column will be rate, and my third column will be time. So I have distance equals rate times time. I label my columns at the top. Now I'm splitting the box into 2 pieces because I have a trip to grandmother's house and then a trip returning home. So to and then return. Just label those so I can keep track of it. And so each of these cells represent, for example, this cell represents the distance going to grandmother's house. This cell represents the rate going to grandmother's house. So let's put the information that we're given into our graphic organizer. My students call this a dirt box, so that might help you remember the distance equal rate times time, dirt. So she drove to her grandmother's house for a weekend visit and averaged 40 miles per hour. So the rate, we know this is rate because it's miles per hour. The rate to her grandmother's house is 40. Returning home, now we're going to be in this row. Returning home, she was able to average 48 miles per hour. So again, that's your rate, but it's the return rate. So 48 gets placed in this cell. And her driving time, so this is still the return home. So the return home time was 1 hour less. Well, 1 hour less than what? We can gather from the problem that it was 1 hour less than her time to go to her grandmother's house. So if we let T be the time to her grandmother's house, then returning home, her time was 1 less. Now 1 less than T will be T minus 1. All right. We also have blanks here on the distance, but we should gather from our problem that if we're going somewhere and then returning home, that distance will be the same. So I can let my distance to grandmother's house be D, and my distance returning home is also D. Now be careful when you're assigning variables not to assign too many, because remember, if you have 2 variables, see, we have a D and we have a T. If you have 2 variables, you have to have 2 equations to solve that. If you have 3 variables, you have to have 3 equations, and so forth. So we're going to need 2 equations. We can get each of those equations from the rows of our dirt box. The first row, remember this is distance equals rate times time. So my first equation is d equals 40 times t. My second equation comes from the second row, and this one is d equals 48 times, and I'm using parentheses because I have a binomial there for my time, t minus 1. So these are the two equations that I need to solve, and I can solve those simultaneously. Since both of the right sides are equal to d, I can set the right sides equal to each other. So I can say that 40t is equal to 48 times the quantity t minus 1. Let's remove the parentheses on the right side. I'll copy the left side. 48 times t is 48t. And then 48 times negative 1 is negative 48. Let's subtract 48t from both sides. These will cancel, and I have 40t minus 48t is a negative 8t, and that equals a negative 48. Divide both sides by negative 8. These will cancel, and I get t is equal to 6. Now we're not finished here because our question says, what is the distance between Carissa's home and that of her grandmother? So I'm not looking for time, I'm looking for distance. But I can take one of these equations, I'm going to take this smaller one here, and do some substituting. So I have d equals 40 times t. Now I know that t is 6. I can say that d is equal to 40 times 6. 40 times 6 is 240, so d equals 240. And my distance then, I need to go back up here. My rate was miles per hour, so my time was hours and my distance was miles. So my answer then is 240 miles.